Hello everyone, welcome to USEF Study. In today's video, I'll be teaching you about isotope and isobar. Let us begin. Did you know that the number of neutrons of an atom can increases or decreases? Also, the number of electrons can increases or decreases, but the number of proton or atomic number will always stay the same. For example, one type of hydrogen atom has one neutron and one proton. Another type have 2 neutrons and 1 proton. This type have 0 neutron and 1 proton, while this type does not have electron. The number of protons stay the same because it is unique to every atom. In other words, every atom has their own atomic number, and they cannot share this atomic number with other atoms. In addition, atomic number is more than a number. Atomic number allow atoms to keep their identity. Therefore, we can use atomic number to identify elements or atoms in the periodic table. Let's say someone asks you, an element X has atomic number 11. What is the element? Right, the element is sodium, because in the periodic table, only sodium has the atomic number 11. Just like the way the name of a person is unique so that we can identify them. Also, atomic number is unique to an element so we can identify them on the periodic table. I recommend you watch my video on atomic number and mass number if you have not watched it already, as this will allow you to fully understand isotope and isobar. In this lesson, I will be discussing atoms that can have different number of neutrons in details. Atoms that can have different number of electrons will be discussed in separate lesson. Back to the type of hydrogen atom we talked about earlier. It can also be represented like this, each with one written on the top, one written on the bottom. The top number represents the mass number, while the bottom number represents the atomic number. We got the mass number by adding the number of protons and neutrons together. For this hydrogen, let us write H. The atomic number is 1. Let us put 1 at the bottom. What is the mass number? Right, 2. Because we get it by adding the proton and neutron. 1 plus 1 is 2. Let us put it at the top. For this hydrogen, let us write H. The atomic number is 1. So let's put it at the bottom. So what is the mass number? Think. Right? The mass number is 1. Because neutron plus proton will give us mass number. We have 1 proton. Then we have 0 neutron. 1 plus 0 is 1. Let's put it at the top. We will do the same thing for the last hydrogen. Did you notice that these atoms have the same atomic number but different mass number? The mass number is different as a result in difference in number of neutrons. Each of these atoms are called the isotope of hydrogen. So we define isotope as atom with the same atomic number but different mass number. Again, isotope are atoms with the same atomic number but different mass number. We said there are atoms because we have more than one atom. In this case, we have 3 atoms of them. Now let us talk about how we can differentiate between isotopes of the same atom. Since all the atoms are hydrogen isotopes, there should be a general way to differentiate between the isotopes, right? We simply name them based on the mass number they carry. Let's use hydrogen isotopes to understand this. The first isotope of hydrogen has the mass number of 1. We simply call it hydrogen 1. The second isotope has the mass number of 2. We simply call it hydrogen 2. Can you name the third isotope? Yes, you are right. It is hydrogen 3. If you know that this video helped you, you can support this channel by hitting the subscription button below, as this will allow this video to get to more people. The isotope of hydrogen has another name, which is based on the discovery of hydrogen. The first hydrogen isotope that is discovered is known as the protium, which is coined from the Greek word protos, meaning first. The second isotope is called deuterium, which is coined from the Greek word deuteros, meaning second. The third isotope is called tritium, which is coined from the Greek word tritos, meaning third. This is the most commonly used name for hydrogen isotope. Another atom or element that exhibit isotopes are carbon 12 and carbon 14. Other example is chlorine 35 and chlorine 37. Most elements in the periodic table has 2 or more isotopes, but the most abundant one is written on the periodic table. For example, carbon 12 and carbon 40 are isotopes of carbon. Carbon 12 has abundancy of 88.9%, 14 has abundancy of 11.1%. This is why carbon 12 is written on the periodic table. Other example is chlorine. Chlorine 35 has abundancy of 75%, while 37 has abundancy of 25%. So chlorine 35 is written on the periodic table. With isotope out of the way, let us learn about isobar. I will use this example to explain. Carbon 12 and boron 12. Carbon has the mass number of 12 and the atomic number 6. Boron has the mass number of 12 and atomic number 5. If you notice, we have the same mass number and different atomic number. This is the definition of isobar. Isobar are atoms with the same atomic mass but different atomic number. This will be the end of this lesson. Thank you for watching.